recent times, AI has really come to the forefront with things like ChatGPT.
In an agricultural sense, it's got enormous potential.
It has the ability to process huge amounts of data that I can never get through.
So we can go from a green on brown environment to a green on green environment.
Artificial intelligence will have a positive impact on farming because it will help the process of decision making.
And now it's time to actually visualise the output of the AI system.
Up until recently, artificial intelligence was confined to the realms of science fiction. But in the past year, AI has stormed into the mainstream, reshaping headlines and challenging the status quo. Excitement and trepidation alike have met the potential of AI, as both consumers and industry grapple with its implications. Now we turn our attention to agriculture. What role will AI assume in this field? And are farmers poised for this next wave of digital transformation?
Artificial intelligence really is automating the collection of data and then using algorithms to try and make sense of that data.
In recent times, AI has really come to the forefront with things like ChatGPT. And so instead of being a promise of something to come, people can actually see and interact with it today.
I think the right way to think about generative AI is that it's making all of us who can speak English coders, right? And if you don't know how to code, generative AI is enabling us to put in a problem statement, a request if you like, and the tools like ChatGPT will translate that into code. So you and I can become software coders to develop a solution to a problem that we inherently understand.
In an agricultural sense, it's got enormous potential in terms of machine-based learning algorithms that might help predict crop yields and manage water allocations and fundamentally help drive those efficiency gains moving forward.
The upside of AI is the versatility in terms of the problem spaces that it can address. So we can go from a green on brown environment to a green on green environment, or we can start to look at detecting crop diseases or flowering rates or bulbs for cotton. It lends itself to a lot more opportunities to help the farmer.
It could be counting livestock moving through a race in a field, estimating the weight of animals. It could be when you send a drone up in looking at crop and saying, that looks like a symptom of XYZ. Right? Which could be something that's out of the remit of the experience of the producer.
It's a combination of a variety of systems and people that will harness the potential power of AI to be used. It'll be a combination of agronomists on the ground that have an innate understanding of the local area. It'll be a combination of family farming units and corporate agriculture who are using it.
Because it will help the process of decision making. You know, to hand the power of a decision to a machine, irrespective of the amount of data goes in, there is a confidence element that you miss because a human will ultimately make a decision. It will have collateral benefits and collateral damage at pathways as well. So artificial intelligence will play a big role in assisting decision making, but I wouldn't hold my breath waiting it to make day-to-day farm-based decisions without a producer yet.
Situated just outside of Torwood, northern New South Wales, resides Luke Arbuckle, a forward-thinking farmer who is utilising artificial intelligence to improve the soil health of his cropping operation.
I don't know where the name Warrandyne came from. There's a neighbouring farm called Yarrandyne. I'm guessing it's part of a bigger farm originally. Pieces got chopped off. My family bought it about just under 30 years ago. Father died 12 years ago, and we sort of split up the family business. So my sister's on one farm and I'm here, which makes things a lot easier rather than travelling in between everywhere. Yeah, boy. Yep. Like, one of the challenges when you're farming is moisture and having rainfall or having the moisture held in the ground. So if you let the weeds get away and you can't get control on them, you might have to do tillage, in which case you're losing ground cover and you're drying out the soils and you're causing a lot more damage, and that can have consequences for a couple of years while you're trying to build up that soil carbon and that ground cover again. So yeah, having that weed control is probably the biggest challenge that we face. We got fleabane here, which is a big problem. I mean, it's got thousands and thousands of little seeds, and it's getting very, very resistant to herbicide and harder to kill. Like, it can tap in multiple times onto the ground as it grows and just sucks the moisture out and just makes the ground dry and hard compared to soft soils that have moisture in it. Like, that's beautiful. That's just ideal. And where this has been, it's just taken so much moisture out. Just made it hard, cloddy. So I don't think I'll be getting anything to grow where this weed is. When it's hard like this, you're not getting water to infiltrate, and it's harder for plants to grow. It's harder to plant. Just makes the crop hard to establish and hard to get yield. We need the moisture in the soil to be able to grow a crop. And when plants take it out, it's not available for the next crop. Here we've got a milk thistle. It's not the biggest problem weed we have, but it causes issue, and here it is isolated. If we needed to spray the whole area, that'd be costing us a lot more money than spraying just this one weed. But even when we're doing everything right, we still get this causing issues in places because it's just got extremely light little seeds that can just blow hundreds of meters or kilometers. So it ends up being a problem in the middle of paddocks that you think you don't have a problem in. Weed control costs hundreds of thousands of years for my operation, and if I wasn't to do it, I wouldn't be cropping. The cost of chemicals that we use is just going up. I mean, we've got the input sort of prices increasing, and we've got the amount of chemical that we have to use to kill these weeds that are getting more resistance increasing. So, like, individual ICBs here can cost $10,000, and we can go through them in a day. And our cost per hectare, like, it used to be sort of achievable about that $10 to $15, where now we're regularly hitting $30 per hectare for one spray, and we're more often doing multiple passes, so it'll be having to go across that paddock twice, with some of those spray costing $30 each time to get the same level of control we used to. But yeah, we're starting to see solutions to this where we can just target individual weeds. The stuff that Jerome's doing with artificial intelligence, being able to start identifying weed species as well and target herbicides just for those weeds, will be a real game changer when we can use the exact chemistry to kill that weed.
Infarm, located 115 kilometres down the road in Gundawindi, is an Agtech pioneer who is bringing artificial intelligence into reality for the agricultural industries.
I first met Luke because he got in contact with me. I believe he was complaining to a local machinery dealer, and he was complaining about this problem that he had weeds, and surely there was a way that his tractor could spot spray and only spray where the weeds are.
When I was farming and having weed issues and looking at the solutions, one of the things that struck me was I've got this very expensive sprayer rig with the ability to turn on individual nozzles in different ways, but there was no software or solution to actually use that technology I already had to target weeds, even though it was capable of it. And I was complaining about that, and they said, oh, there is someone doing that. And they mentioned Jerome was doing something with artificial intelligence and targeting fallow weeds.
And so Luke and I went to the cafe, and he was asking me a lot of technical questions, almost like as if he was trying to pry the information because he wanted to build a competing product. And as we got through the conversation, it was obvious that he was there looking for a technology solution. He had a pretty good understanding of what the technology could potentially do, and you could see that what we were developing was the future and could be integrated into his farming system.
Initially, when I met Jerome, he was quite guarded, because he was worried that I was going to try and steal his idea. But we were talking about the tech and then more and more just around like the opportunities to AI to solve other problems as well. And it was really engaging and really impressed me. Like, quite a vision for what it could do. Like, I wasn't even really aware of AI outside of sci-fi movies. The way that AI is being used on the farm now, a drone's currently coming out to capture it. All of the photos are taken from above, having the GPS position like extremely accurate, and then the files are taken onto a server where multiple passes of algorithms and artificial intelligence are looking for features that it knows could be a weed, and is working off of probability models and every other bit of witchcraft that goes on for AI to find exactly, this is the weed, this is the location. And then all of those analysis over the whole paddock is stitched together and then converted into a file that can go into my spray rig and just allow my spray rig to turn on and off where there is a weed, and use a lot less chemical.
Artificial intelligence is core to the technology and the platform that Infarm has developed. And so when we look at our weed detection platform, AI sits at the ability to identify those weeds or those plants. And so what we do is we collect a lot of different types of information, different weeds in different contexts, in fallow, in crop, in pasture, and we look at detecting that plant and understanding that context and feeding that data to an AI system so it learns how to identify that plant. Now, once we've trained that AI system, what we do is we then feed it new images and ask it to locate where those plants are. And it's from that identification that we can then start to identify its GPS location and provide that information to the tractor. So what's happening here is we're looking at flying the paddock to identify the weeds. We're operating the drone, and what it's doing is it's flying a predetermined flight path to be able to take photos and identify from a GPS point of view where those photos are being taken. So right now we're producing about 10 gigabytes of data per hour from this one drone sensor. The quantity of data that we're producing is quite significant, and so ensuring that we have the correct data management systems allows us to deal with large quantities of data, especially in environments where we don't necessarily have connectivity and the internet. Once this drone lands, what we'll do is we'll get the SD card and upload those into the computer, and from there all that gets synced to our processing system where we identify where the weeds are and triangulate their location, so we can provide that information in the form of a prescription that gets uploaded to the tractor via USB. Righto, so we've gone and collected the data from the drone. The aim of the game is to then upload all the images to the system so the AI can go and process it, identify where the weeds are, and then create the prescription from there. And now it's time to actually visualise the output of the AI system. So this image is basically the image of where all the weeds are and what the AI actually sees when it's trying to interpret and identify where those plants are. From there, we click the actual prescription,
And what will happen is that the location of those weeds will become obvious, and this is precisely where we need to actually go and spray. So if I go and zoom in to a group of weeds, you'll see that the plants are literally here that need to be sprayed. This is precisely the information that is needed by the tractor to go and actually spot spray and only spray where those weeds are.
Prescription's already been copied onto the USB. Just need to select where I'm doing the work, so the farm and the field. And then I'll load up the prescription, so rather than fixed rate, I'll use the pre-populated map that was generated by the AI. Load the file, load what I want it to be triggered by, which is that. And we're right to start. So now I simply drive to the paddock and start the job. Rather than drive manually, we use Precision Agriculture Solutions to load in the heading and the line we want to follow, press the button and let it steer itself. And we can see there's a whole series of weeds coming up on the left-hand side, and we can watch what happens with the screen as it triggers and turns the nozzles on, just in the locations where the weeds are. Looks like the nozzles are triggering exactly where the weeds are and not spraying where there isn't any weeds, so saving us money. So coverage-wise, it's doing about 3 or 4% of the paddock rather than 100%.
When you look at the ag landscape, people tend to have certain types of machinery. So whether it be green, whether it be red, whether it be blue. And each of them has their benefit and their limitations. And what we've done is be able to integrate with any of those machines and really leverage the capacity of that machine to bring spot spraying capabilities to them. And what that means for the farmer is that they don't have to go and buy expensive equipment, and we can leverage the current technology that they have and really drive home and deploy agricultural technology to the farm gate.
Like being able to use this without having to invest heaps of money in a whole new machine is a huge thing to making this so available and easy to do. Like, it's quite an impediment to make changes to your system if it's got a huge capital outlay, and there's no capital outlay in now targeting weeds through this method.
When you look at spraying, there's different types of scenarios for farmers. So quite often you'll hear about green on brown. So that's looking at a fallow paddock and detecting if there is plant matter, if there's something that's alive. You've also got the other context in farming, which is green on green. So looking at trying to detect and differentiate weeds from the crop and only spraying those weeds.
Green on brown, the fallow weed control, is a huge thing to be able to drop the costs in that fallow period. But there's just going to be immense opportunities with like the green on green technology, being able to identify individual species, target chemistries to those species. If you can manage one individual weed and go, well, this is this species, then you can start using that big data and AI to actually manage individual plants in your crop. So this plant is low on nitrogen, this plant is low on zinc, or this one doesn't have the yield potential. And then you can start having management of individual plants in your paddock, which will really change things. Like even when it comes to disease, and we don't even know all of the things that'll be capable, because there's stuff that it'll be able to spot. Like anything we can go into a lab and look at the individual plant right up close, it'll be able to do on the scale of whole paddocks.
We've already developed systems that can do green on green. So we did a project down in New South Wales where we mapped 200,000 hectares and in pasture and identified where certain types of weeds were. And from there we could create a landscape or a region-based management plan to manage those weeds. So the ability to do that green on green is already embedded in our technology, and that's part of the reason why we leverage artificial intelligence. That ability to do region scale mapping, to process that information without the cloud, is one of the core things that we've developed. And we've worked hard with some of our partners, including Dell and Microsoft, to bring that to reality, because this technology requires a lot of data. And when you're operating in an environment that doesn't have cloud or the internet, the ability to deliver that in near real time, no cloud, no internet, is something that is really quite remarkable. And it now means that we can deploy this technology to any farmer anywhere in the world, no matter what their connectivity context really is.
The biggest benefit I have using AI with Infarm is that the cost for some of my sprays are just dwindled away, and it hasn't had a massive capital outlet. I'm using stuff that I've already got, but there's so many follow-on benefits as well, like keep maintaining this data, the terrain modelling stuff that's come out of these images as well to manage water flows, direction of farming, and other just small benefits, and they just start to add up to be quite significant gains when you can use the same piece of information, which is just a drone flying over the top, and use the analysis to give you a lot of different benefits, not just that cost of chemical or more effective sprays. The artificial intelligence has the ability to process huge amounts of data that I can never get through and start to make links that we maybe don't see. You can start to model what water does when you get rainfall. You can start to feed it the soil tests spread over your farm and start to see if links can be made with existing data sets you have, and then be able to provide that information out on a much finer grain. Like, I can't walk around to manage every inch of my farm, but with AI and that analysis of whether it's water flows, water levels, water holding capacities, nutrient levels in soils, fertiliser, chemical use in different soil types. So yeah, we just don't know how far it'll be able to go.